Next topic is continuous time Fourier series or CTFS. Any signal which is periodic can be expressed can be represented using continuous time Fourier series. Means the continuous time Fourier series is applicable for the continuous time periodic signals only. We can't express any non-periodic or aperiodic signal if it is continuous also. It cannot be represented using continuous time Fourier series. ഒരു കണ്ടിന്യൂസ് ടൈം സിഗ്നൽ എക്സ് ഓഫ് ടി ഉണ്ടെങ്കിൽ അത് പീരിയോഡിക് ആണെങ്കിൽ മാത്രമാണ് നമ്മുടെ കണ്ടിന്യൂസ് ടൈം Fourier സീരീസ് ആപ്ലിക്കബിൾ ആവുള്ളൂ. നോൺ പീരിയോഡിക് സിഗ്നലാണെങ്കിൽ അതിന് Fourier സീരീസ് ഉണ്ടാവില്ല, Fourier ട്രാൻസ്ഫോമേ ഉണ്ടാവുള്ളൂ. രണ്ടും കൺവേർട്ട് ചെയ്യണത് ടൈം ഡൊമെയിൻ ടു ഫ്രീക്വൻസി ഡൊമെയിൻ ആയിരിക്കും. എങ്ങനെയാണെങ്കിൽ തന്നെയും Fourier CTF is applicable only for periodic signals and it is not possible for non-periodic signal. That is the notable thing. Second one, non-periodic signals cannot be represented using CTFS. By CTFS, we can represent any signal as the combination of a DC or constant or zeroth harmonic component, a cosine component, and a sine component. The things to be noted is these 3 points are applicable if we are using trigonometric Fourier series. We have some other Fourier series also, like polar Fourier series, complex exponential Fourier series, like that. And these 3 points are applicable only for trigonometric Fourier series. Okay, any signal x of t that can be represented as the combination of a DC component, a cosine component, and a sine component if by using a CTFS. Okay, and these 3 things are applicable only for trigonometric Fourier series. Okay, next thing is the how to evaluate the trigonometric Fourier series. Okay, any continuous time signal x of t can be represented by using Fourier series by the combination of these 3 components that we have already told about that. Okay, then by trigonometric Fourier series, x of t can be represented as x of t is equal to a0 plus sigma n equal to 1 to infinity a n cos n omega suffix 0 omega t plus bn sin n omega 0 t. Okay, this one is the DC component a0 and an cosine of n omega t, that is the cosine component, and the third one is the sine component. Okay, where DC component a0 is equal to, before that let us mark it as equation number 1, and next the DC component a0 is equal to 1 by t0 integral x of t dt. Okay, where t0 is the fundamental period of x of t. 0 is equal to 1 by t integral over x of t dt. Okay, which is the DC component value. And second one, an is equal to 2 divided by t0 integral x of t cos n omega 0 t dt. That is the equation for a. N is equal to 2 by t integral x of t cos n omega 0 t dt. And bn is equal to 2 divided by t0 x of t sin n omega 0 t dt, where t0 is the fundamental period of x of t, and t0 is equal to 1 by f0 is equal to 2 pi by omega 0. Okay, where omega is the angular frequency in radian and f0 is the frequency in hertz. Now we have some points to be remembered. If the periodic signal x of t is symmetrical about the time axis, not that about the time axis, then a0 is equal to 0. Okay, if the signal is symmetrical, signal shows symmetry about or with respect to the time axis. Time axis means we have amplitude along y-axis and time along x-axis. This is the basic representation of a signal, in which amplitude is expressed along the y-axis and the time along the x-axis. So, if a periodic signal x of t shows symmetric about the x-axis, that means the time axis, then a0 will be 0. For example, consider this is signal. This signal shows that this is the x-axis or time axis, and this is the amplitude axis. This signal shows symmetry in about the vertical axis. Sorry, about the horizontal axis. That means the time axis. So signal shows symmetry in x-axis also. That will be considered later. Now what we have to analyze is the signal shows symmetry about the horizontal or time axis. Now consider this signal also. This also shows or exhibits symmetry about the horizontal axis. In this case also a0 will be 0. And finally consider the signal. This is not symmetric about the horizontal axis. So in this case a0 will not be 0. Okay, got it? Okay, now let us go to the second point. If the periodic signal x of t represents an even function, only cosine terms in Fourier series exist. Okay, that means Bn will be 0. Okay, if the signal is an even signal, means a cosine signal, that is an even signal. that in this case an even signal should have only bn equal, no, should have bn equal to 0, and that signal should consist of only the cosine terms only, means only an component exists, bn should be 0. Okay, right. And the last point is if the same signal, if any signal which is that should be periodic, okay, right, and is a periodic signal x of t, if it is an odd function, then only sine term should be present in the Fourier series, and in this case n is equal to 0. If let us revise this portion once again. If the signal exhibits symmetry in the time axis, and n is equal to 0, and if the signal exhibits symmetry in the vertical axis, that means if the signal is an even function, then only cosine terms present should be present and bn equal to 0. And if the signal is an odd function means if the signal shows anti-symmetry about the vertical axis. Okay, if the signal shows anti-symmetry in the vertical axis, then that series should contain only the sine terms. In that case, n is equal to 0. Here, if the signal shows symmetry about the horizontal axis, then only a 0 exists. If the signal gives symmetry about the vertical axis, or if the otherwise, if the signal is an even signal, of course, that should give symmetry about the vertical or amplitude axis. In that case, only cosine terms exist. And last one, if the signal gives anti-symmetry about the vertical axis itself, means if it is an odd function, then only the sine terms present. And